So, we have, meaning Madame Hill and myself, have corrected the tests. I have one of the classes in the grade book, but then I was answering questions in the resource center, so I couldn't get the other one in the grade book yet.
Excuse me.
So I have, for mine, it's 4 through 6 is in the grade book. And then 1 through 3 I'll get in a little bit. Okay? So give me about 40 minutes after class is over with, and I'll get them in. You'll get them back tomorrow. Okay? So yeah, so that's where we're at. Okay? So today we are going hardcore trig today. Okay? So around the room, and this those people watching along with us via the interwebs is going to be hard to see, but around the room you will see multiple examples of the unit circle. Okay? We're going to start developing the unit circle today. Up here, you've got unit circle balloons. Okay? A painting. Back there by the TV, you got a unit circle dream catcher. Above Molly, you've got a unit circle art palette. Below that, you got a unit circle minion. Over here, you got another unit circle minion. You've got a unit circle mobile. You got Mr. What's the guy's name from Up? The old guy, yeah. Yeah. But you got the Up unit circle. Back there on top of the shelf, you got looks like a unit circle sucker, we'll say, and then a unit circle UFO. And we used to hang the UFO from the ceiling, but then the fire department said, Mr. Fredrickson, that's it. Mr. Fredrickson, and what's the kid's name? Chubby Bunny? No, that's a game. Okay. It's not Kevin, because Russell. Yeah, because Kevin's the bird. Yeah, so it's Russell and Mr. Fredrickson over there.
What about the dog?
Doug. Squirrel. I hate to watch that. I love that. Okay. So, the unit circle is super duper importante to us. So, we're going to take some time today and tomorrow to develop the unit circle. Okay? We're going to work on getting those sweet 16 points all on there. Okay? And then utilizing it as we're going along. Okay? So, in order to do that, we got to start with a basic unit circle. Okay? So, right now you can just draw a smaller one. In a little bit, I'm going to have you draw a much larger one so that we can develop it as we go. Okay? I'm not a Gray fan. I'm a Goldenrod fan. Yeah. Okay? So, the unit circle, oops, I guess I can't sketch. Somebody's going off. Somebody's blowing up. Super important. Exactly. Gosh, what do they want? Okay? Alright, so if I think back to the equation of a circle, x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. That's the equation of any circle that has a center at the point h, comma, k, and it has a radius of r. Okay? The unit circle is a circle with a radius of 1. Okay? That's the unit circle. It's 1 unit. Okay? Hence why we call it the unit circle. Okay? So that means then that the equation of my circle, I knew that was going to do that. I saw it. I saw it, and I saw it. Come back to me. Baby, come back. Okay, I saw it when I was walking over here. It was jumping around a little bit, and I said, that sucker's going to move on me as soon as I get back there. But anyways, we'll get it when we get rid of the shade. Okay, so I want you to draw me a circle with center at the origin. And a radius of 1. Okay? So you can draw any circle, and then just your radius is 1, and your center is at the origin. Okay? All right? So now what we're going to talk about is we're going to talk about some t values. Okay? See, there it is. Got to get rid of it now. Okay? So each and every t value or RAP value corresponds to a point that's on that circle. What I mean by that is this. I'm going to draw in a new axis. I'm going to draw it in right there. It's going to go through the point 0, 1, because that point's on my circle. Right? And what's going to happen there is I'm going to take any t value here. So this is my, oops, I should write this first. This is my t axis, and it's my RAP value. It's, dare I say, wiggity, 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 whack. Okay. All right. So I'm going to take my RAP value, set it right there. So that's my t value. And what's going to happen is I'm going to bend that, and I'm going to bend that along my circle here. Okay? So that there is my value. Okay? So t now, okay, whatever t is, whatever I make t, I can make E4. Okay? And I'm going to bend 4 around the circle. Understand what I'm saying there? Okay? And I could go in either direction. I could go positive values of t. I could go negative values of t. But either way, what's going to happen is I'm going to set that value, and then I'm going to wrap it onto my unit circle. Okay? So I can go all the way around my circle. I could go twice around my circle if I wanted to, but it's going to wrap all the way around. Okay? So, knowing what you know, come on now. Knowing what you know about that, then, so now my t here is my arc length, and theta is my central angle. Okay? So, if we remember back to the arc length is equal to theta times my radius, my arc length was t. Theta, I don't know. And what's my radius? 1.
So then just T equals
T equals theta. So theta is T in radians. Now, we can use some, knowing that fact that T is equal to theta, we can come up with our 6 trig functions. They're the bedrock, the foundation of this class. Okay? So, the first one is cosine. Okay? Cosine, the abbreviation for cosine is COS, but you still say cosine. Okay? You don't say cos or cos. Okay? I'll look at you funny. Okay? Or cost. Okay? You say cosine of t. Okay? That is equal to the x value of my point. Okay? So if I go back a slide here, now, the x value of this, we'll call it red dot, the x value of that red dot is equal to the cosine of that central angle. Okay, that's what that's saying. The x value of that red dot, because that's a point in, it's got an x comma y. That point, the x value, is equal to the cosine of my angle. Okay? The sine of my angle, the abbreviation for sine is SIN, is then y. So the y value of that point is equal to the sine of that central angle. Okay? Those two, you should clear out a space on your cluttered shelf inside your brain and put them there and prominently display them. Like you want to buy an under cabinet light so that the light shines down upon those two facts. Okay? All right? Tangent of t okay. Abbreviation is TAN, but we're never going to say tan for it. Okay? Okay? Tangent of t is equal to the sine of t over the cosine of t, or it's equal to y over x. Okay. Now I'm guessing, back when you were in geometry, you did some right triangle trig, and you knew about sine, cosine, and tangent. You probably heard the story of SOHCAHTOA. Probably Queen SOHCAHTOA. Do they still teach you that one? Queen SOHCAHTOA and her going to the ball. Okay. In trig, we've got 3 more. I almost said 6 more, but we've got 3 more to go along with it. Okay. Secant, cosecant, and cotangent, okay, are our new ones today. Okay. Now, the rule is in trig is that everything needs a co. Okay? With me? Everything needs a co. So, tangent needs a co. So that's why we have cotangent. Okay? Alright? Cosine already has the co, right? So cosine goes with secant. So the secant of t is equal to the SEC of t, so that's the abbreviation. Okay? And it's 1 over the cosine of t. It's the inverse of cosine. Okay? Or the reciprocal of cosine. So that would be 1 over x. Sine needs a co, so that's cosecant. So cosecant is the reciprocal of sine. Cotangent, or cot, okay, is 1 over, did it again, like my t's, or 1 over the tangent, so that would be the cosine of t over the sine of t, or x over y. Okay? Yes, ma'am.
Is that cosecant as over S? I mean, not
SEC.
for the cosecant, is it?
CSC. Do you want me to change that first C?
I thought it was like state.
No.
Oh.
Is that better?
Yeah, exactly.
No problem. Okay.
You didn't hear that.
All right. I heard ESC. Yeah. Escape. The escape clause. Okay. So I'm going to give you a point on the circle, or on the unit circle, and I want you to find me the 6 trig values of t. Okay. But first, I'm going to ask you, is that point on the circle? How do we know if any point is truly on a circle? Well, what do we have for that circle? How do I know if any point is on that particular unit circle? Do I have an equation? No? X squared plus y squared equals 1 is the equation of my circle. Right? Do I have an x value? Oh, put that calculator away, sister. We don't need no stinking calculators. Do I have the x value of my point? Yeah, it's what? Negative 5/3. So this would be negative 5/13, not 5/3, but negative 5/13 squared, right? Do I have the y part of my point?
You do?
What is it?
Negative 12.
Negative 12/13. And if I square those and add them up, I should get 1. If I don't get 1, then that point is not on my unit circle. Okay? So what is negative 5/13 squared? Should be able to do this without a calculator. Nope.
Oh.
Negative 5/13 times negative 5/13. Negative 5 times negative 5. 13 times 13. Negative 12/13 squared. 144? 144 over 169. I like that a lot better. $25 169ths plus 144 169ths. 169 over 169, which is 1. So is this point on the unit circle? Yes. So since it's on the unit circle, now we can utilize all of these relations to find our 6 trig functions. So my question is, what is the cosine of t? Dylan. Bingo. Negative 5/13. Why is it negative 5/13? The x value of my point. Nice job, Dylan. Okay? What's the sine of t then? Because why? It's the y value of my point.
Oh, that's why.
Okay? So, now, here we go. Everything needs a co, right? Okay? So what's the one that goes along with cosine? Secant, because it only needs one co. Okay? So the secant of t is what? I like negative 13/5. It's reciprocal, right? What's the co that goes with sine? Cosecant? Did I draw it better, Tasha? Okay. What's the cosecant of t? Negative 13/12. Okay. Now, we got to do a little bit of math. Because now, we have to come up with tangent. And cotangent. Okay? So the tangent is going to be what? Y over x, correct? So that's going to be negative 12/13 divided by negative 5/13. When I divide by a fraction, I do what? Multiply it by its reciprocal. So this is going to be negative 12/13. Whoops, that's a bad. Times 13 over negative 5. Without a calculator, what is it? 12 over 5.
So couldn't you also cancel off, for this purpose of it, couldn't you also cancel off the 13s on a fraction too?
Which is what we do, yeah. And then the negative divided by a negative makes it become positive. So this one then is 12. Oops, wrong color. OCD kicking it. 12/5. What's the cotangent then? 5/12. And there are your 6 trig identities that go along with that particular point. Okay? So now, what I would like you to do is I would like you to start a brand new page. Okay? And in the top half of that page, I would like you to draw a big unit circle on the top half. And the bottom half is going to be where we're going to do our math. Okay? Because we've got to come up with the sweet 16 points, the nicitude points on it. So on the top half, put a unit circle. On the bottom half, leave that open to do some math. Okay? Put the crosshairs in there too.
Right, crosshairs.
Okay? So there are 16 nice points on the unit circle. Okay? We'll start with the easy ones. 1, 0 is on the unit circle. Yes? Okay. In trig, that is at 0 degrees or 0 radians. Okay. The symbol for a radian is, instead of the degree symbol up in the above in the exponent spot, if you will, having the circle there, it's an R up there. Okay? So, now let's go up to here. So if I go up there, that's the point 0, -1, right? Degree-wise, how many degrees did I go? Oh, +1. I don't know why I put -1.
Oh, come on, you're a math teacher.
You didn't pick up on it.
Because I was waiting for you.
Okay? Degree-wise, how many degrees is it? 90 degrees. Radians-wise, how many radians is it? No.
1 pi over 2. 1 pi over 2.
It's pi over 2. If you convert 90 degrees into radians, you get pi over 2. Okay? All right. Let's go 90 more degrees. So now I'm at the point -1, 0. In terms of degrees, where am I at? I'm at 180 degrees. In terms of radians, where am I at? I'm at pi radians. Okay. If I go down here now, I'm at 0, -1. Move this stuff down a little bit more. In terms of degrees, where am I at? I'm at 270 degrees. In terms of radians,
2 pi over 3.
nope, 3 pi over 2. Okay. if you think about it, 90 degrees to get to here, or pi over 2. So 1 pi over 2, 2 pi over 2, then 3 pi over 2 down here. Okay? All right? Now, if we went another 90 degrees, where would we be at in terms of degrees? So this is also 360 degrees, or 2 pi radians. Okay? So that's 4 of our 16 points. Okay, which ones do you want to do next? The 45s. Okay. So if I drew in a 45-degree angle in terms of radians, how many radians would that be? Radians. Convert 45 degrees into radians. Pi over 4 radians. Okay. What would the x and the y coordinates be for that point? Is it going to be 1/2 and 1/2? Well, let's think about it. 1/2 and 1/2 quickly. 1/2 squared plus 1/2 squared is 1/4 plus 1/4, which is 1/2. Is that equal to 1? No, so it can't be 1/2 and 1/2. So what we want you to do tonight is, I want you to think back to when you were a tree. Okay, in geometry, here's your triangle. I want you to solve me for y, and I want you to solve it for x. Okay? And that's where we'll pick up tomorrow on our unit circle. Okay?